For our first lab, charge tape, we go over charge, a property of matter, and we model this property by using tape. Some matter can be charged by physical contact with other matter, and the purpose of this lab is to charge matter, in this case, the Scotch tape, and see how that charged matter interacts with other objects, whether neutral or charged. This lab mainly goes over the principles of electric fields and the electric force, which are used to calculate the overall charge on the tape. By suspending two charge tapes one above the other and measuring the distance between them, we can solve for the numerical value of that charge. Using the charge, the lab also goes over how to find how many electrons were transferred and how many atoms lost or gained those electrons. For the first part of the lab, we hung a charged piece of tape off of the ledge or of a table or a bedside, and put our hand near it and found that the tape was attracted to our hand and other neutral objects. Then, I charged a pen by rubbing it against a cloth, giving it a negative charge, and found that the negative pen attracted the top tape, meaning that the top tape or the upper tape had an overall positive charge. For the second part of the experiment, I had one upper tape suspended above another, separated by a distance d. Since both tapes are upper tapes, we know that they have the same charge. I found that the top tape began to float away from the bottom tape when they were 2.8 centimeters away from each other. We also assume that the two tapes act like point charges to simplify our calculations. Knowing that the momentum of the system is not changing, we know that the force of gravity is equal to the electric force. Using these two things, I came together to find that the equation for charge is equal to the square root of the distance squared times mass times gravity constant divided by the constant 1 over 4 pi epsilon naught. And using this equation, I found that the total charge on the tape was equal to 13.1 nanocoulombs. By using the charge, I was able to find how many electrons were on the tape. And I found that by dividing the total charge of the tape by the charge of just one electron. And I found that the total number of electrons transferred was 8.19 times 10 to the 10th power. Using the area of the tape and the length of the atom, I found that the number of atoms on the sticky side of the tape was equal to 4.02 times 10 to the 7th power, meaning the ratio of transferred electrons to atoms was 2036.7. Using GlowScript on a computer, I modeled our scenario with 2 point charges and 4 arrows. The point charges represented the tapes, and the blue arrows represent the electric force, while the green arrows represent the force of gravity. I also told the program to type out the answer of 13.1 nanocoulombs. When you're doing this experiment, it's important to know that if the charges of electrons and protons were switched, it would repel from a negative charge instead of attract. And handle the tape as little as possible, because when the tape comes into contact with other matter, it loses its charge.